Howdy! In this mini lecture we will discuss U.S. laws that regulate air quality, types of smog, and how geography can influence air pollution. The student learning objectives of this mini lecture are: explain the fundamentals of the Clean Air Act, including the NAAQS, describe methods to reduce air pollution, distinguish between industrial and photochemical smog, and identify the cause and effect of thermal inversion. Thanks in large partly to the Clean Air Act, originally written in 1963, but revisions and amended in 1970, 1977, and 1990, air quality in the U.S. has significantly improved. The Clean Air Act funds research for pollution control, sets standards for air quality, limits on emissions, allows citizens to sue parties violating the standards, and introduced a cap-and-trade program for sulfur dioxide. The Clean Air Act gives the EPA the authority to set standards for emissions through National Ambient Air Quality Standards. These are standards for any pollutant that may be harmful to human health. Most states have an agency that monitors air quality and other environmental conditions and reports back to the EPA. The EPA, on the other hand, develops, implements, and enforces environmental regulations that the state agencies must abide by. States submit their plans for monitoring pollutants and adhering to the regulations to the EPA for approval. In Texas, we have the Texas Commission on Environmental Quality, abbreviated TCEQ. The EPA can take over monitoring at the state level if it is determined that the state plans are inadequate. As can be seen in the two graphs on the left of this slide, total emissions of the 6 monitored pollutants have declined significantly since the Clean Air Act of 1970. This reduction comes despite increased pollution, energy consumption, miles traveled, and gross domestic product. Other things that have helped reduce air pollution include federal policies and technology. We now have cleaner burning engines thanks to catalytic converters. Catalytic converters filter pollutants from vehicle exhaust. The hydrocarbons, carbon monoxide, and nitrogen oxides produced by the burning of gasoline in the engine are removed by the catalytic converter, and in their place less harmful gases such as carbon dioxide, water vapor, and nitrogen gas are released. Clean coal technologies, such as the diagram of the scrubber in this slide, have also been helpful in reducing air pollution. Finally, federal permit trading programs are also very effective. Recall that the program for sulfur dioxide was largely responsible for reducing sulfur dioxide emissions below the target level. The reduction in outdoor air pollution since 1970 is one of our greatest accomplishments as a nation. But despite the fact that concentrations of all the criteria pollutants except tropospheric ozone have fallen well below the health and safety standards set by the EPA, there is still much more we need to do. There are now concerns over new pollutants and greenhouse gas emissions. For example, U.S. carbon dioxide emissions increased 44% between 1970 and 2008. In 2012, the Supreme Court ruled that the EPA could regulate carbon dioxide as a pollutant. However, there is formidable political opposition to this ruling. Consider this, though. We were able to reduce emissions of many major pollutants by 60% while expanding our economy. Why couldn't we do the same thing for CO2 and other greenhouse gases? We have also reduced emissions of toxic air pollutants, which are pollutants that can cause cancer, reproductive defects, or neurological, developmental, immune, or respiratory problems. The EPA regulates 188 toxic air pollutants. Examples of toxic air pollutants include mercury from coal-fired power plants, VOCs such as benzene, which is found in gas, and methylene chloride, which is found in paint stripper. These and other toxic air pollutants need to be regulated because they can cause cancer in 1 out of 28,000 Americans. Clean Air Act regulations have helped to reduce emissions of these pollutants by more than 35% since 1990. You may have heard the term smog before, but could you define it and explain it clearly? Smog is an unhealthy mixture of air pollutants that form over cities as a result of fossil fuel combustion. There are 2 types of smog, industrial and photochemical. We will now examine each of these separately. Industrial smog results from fossil fuel combustion. When coal or oil is burned, a portion of it fully combusts, while the rest is either partially combusted or completely unburned. During the process of burning fossil fuels, sulfur dioxide is formed. Industrial smog is composed of this sulfur dioxide, small amounts of sulfuric acid, and the particulate matter produced from burning fossil fuels. Carbon dioxide and carbon monoxide are also industrial smog. Industrial smog is colored black-brown and can settle a haze over industrial cities. Industrial smog can turn deadly when combined with thermal inversion. Thermal inversion is a common type of inversion that occurs in mountain valleys where slopes block morning sunlight and keep ground-level air in the valley shaded and cool. Because cooler air at the bottom of the inversion layer is denser than the warmer air above it, the air resists vertical mixing and remains stable. Vertical mixing is needed because it allows air pollution to be carried upward and diluted. Thermal inversion, however, traps pollutants near the ground. This happened in London in 1952. The smog that formed there was called the killer smog because it killed between 4,000 and 12,000 people. A similar event happened in Donora, Pennsylvania in 1948, during which 21 people died and 6,000 people became ill. The second type of smog is photochemical smog. This type of smog forms when primary air pollutants from automobile exhaust reacts with sunlight. The sunlight drives chemical reactions between the pollutants and normal atmospheric compounds and results in the production of over 100 different chemicals, with tropospheric ozone being the most abundant of the compounds produced. Photochemical smog can also be exacerbated by thermal inversion, which is why Mexico City, a city that is both in a warm climate and in a valley between mountains, suffers from photochemical smog. Many students confuse industrial and photochemical smog. The way I tell students to keep them clear in their minds is to think about roots or meaning of each word. Industrial means something that comes from a plant or factory, and typically factories burn fossil fuels. Photochemical includes the term photo, which as a root word means light. Light is the required ingredient to make photochemical smog. If these tricks don't work for you, I encourage you to think of your own methods to keep those two types of smog clear in your mind. We can and we have reduced smog in the U.S. This graph shows peak levels of tropospheric ozone in Los Angeles from 1970 to 2010. Notice that the level of tropospheric ozone has gone down over the decades, but it unfortunately still exceeds state health standards. The reductions were a result of a variety of factors including pollution control technology, vehicle inspection programs, financial incentives to replace aging vehicles, cleaner burning fuels, cleaner industrial facilities, pollution indicator boards, and alternative transportation. Restricting driving and closing industrial facilities that cannot clean up their emissions are also effective strategies. However, these two methods are less popular with the public and industry, respectively. If we are not careful, though, our gains in air pollution reduction may be canceled out by the increased number of cars on the roads caused by a growing global population that is steadily becoming industrialized. That concludes this mini lecture on U.S. laws that regulate air quality, types of smog, and how geography can influence air pollution. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and Gagum!